this time on Art and Code. I'm using OCR software combined with openFrameworks to read the machine poetry on the side of passing wagon trains, firing it through OCR software and combining it to see what kind of poetry can we make from the side of a train. Hey everyone, back again. I'm in the recording studio in Berlin and I wanted to do a short piece. There's a couple of videos that are taking a little bit of a while to edit together, but this is about a piece that I was exploring, so it's unfinished, but I wanted to walk through it with you anyway. So what I'm going to be doing today is making poetry out of freight train, wagon train, cars. The kind of thing that you see transporting lumber and coal and goods across the country on train tracks all the way around the world. And it began when I went down to see an exhibition here in Berlin. So I went to this exhibition, which is down at Saab Space in Berlin. Beautiful, tiny little gallery, volunteer run, had two great shows, one of some geometric painting, another with a video piece by Sebastian Acker. And I shot a bit of video of his work, so this is with huge respect to his work, using that as an inspiration for something that I saw that maybe was not what he intended. But he had shot video out of a moving train of other moving trains, and I think this is across South America. And I've slowed it down here, but it was just a loop of 5 minutes of these trains flying past another train window. So if you've ever done a train journey and you've looked out and you see goods trains and other things flying past, it had this effect. And I was looking at it, this is all slowed down, I was looking at it and realizing there's poetry happening to me. This is machines talking to us again. And I was wondering what they were saying, building this machine poetry with all these bits of words and numbers and so on flying past. So I got super excited going off on my own thing and wanted to see, can I build something that will make automatic poetry? So using this as a, again, Sebastian Acker, thank you very much. My apologies if this isn't a great way to interpret your work, but I was inspired by something that maybe you'd seen in there. To start exploring at the beginning of a piece of work myself. So I want to show you a little bit of the journey that I made to get to, not quite sure where it's going, it's more of an exploration than anything. But I thought I'd give it a go and see what happens when we try to turn freight trains into machine poetry. So in this video I'm going to be working in openFrameworks, and I made a new openFrameworks project, and I took the video that I had shot of Sebastian's work and I put it into the data folder, and I started exploring different ways to do text extraction from images. And one of the things that I came up with that I found worked was OFX Tesseract. So it's using the Tesseract OCR framework and system, and I'll put some description down here. It's using the Tesseract backend. So in my header file, I went and downloaded OFX Tesseract, and within the code for this, it gives you a bunch of different details of how to set it up, how to include libraries, and the different kinds of things that you can ask it to do. In some instances it's very efficient, in others it's less efficient, but I just wanted to get something going. So in my header file here, the first thing that I'm doing is I'm including the Tesseract library, and from their example I have a data struct here for an OCR asset, and the OCR asset has an image, language, and a mode that it's going to ask Tesseract to work in, for depending upon what kind of thing you want to recognize. And then I've got my standard functions in openFrameworks. And then I make a string with OCR objects in, and I've made another string, because what I've found is that as I'm going through, I'm getting all kinds of garbage that Tesseract is saying, I think this is words. Sometimes it's catching pieces of shadow, sometimes it's catching bits of punctuation, sometimes it's catching scrapes and scratches on the side of the wagons. So I wanted to generate text and then put it all together into a string of cleaned up text. So I make an OF Tesseract object, and then I make a vector of the assets that I'm going to add in to ask it to have a look at. I made a video player so I can load and play my video, and I've loaded a TrueType font, and I've set up a couple of things about delaying how often I'm searching for images and so on. And when I got it running, I tried lots and lots of different things to do. And this is sort of what I got. If I run this up full screen. So this is the video that I shot in a gallery, and Tesseract is running and I'm passing it bits of images, and I've asked it to outline everywhere it thinks it's found a piece of text. And then tell me what it thinks that text is. So you can see I pushed this and pushed this and pushed this. It's working off a very, very dirty video, but I'm pushing it to try and find every single thing, and then I wanted to scrape it and clean it up a bit. So I'm passing it frames relatively slowly from the video, and this is very dirty video of video, which doesn't help a great deal. And I'm firing OFS Tesseract over the images and saying, identify where you think you found some text, the red boxes, and then pull me back the text. And you can see next to each box, it's trying to predict what that text is it thinks it's found. And then I'm concatenating that in these strings being printed out with OF TrueType font at the bottom of the screen. And in different versions I was working through, I was grabbing these strings of text and having it build up, thinking, oh, I can make machine haikus. So this is my idea of being able to clean the text. And one of the things that I was going to do after this, and maybe I'll show this in a different video, is taking these pieces of machine scavenged text. You see we found quite a lot of text here and quite a lot of text here, some of which it's finding in the greenery, which doesn't really help. But firing this then at a dictionary, taking out elements of the punctuation, and just accepting whatever the first suggestion for that dictionary was, and then firing that string of random words that have now been turned into real words in a particular language by the dictionary, at something that will give me grammar, and just accepting every piece of grammar and see how much English, or insert your language of choice here, we might get. So this is running away, and you can see I'm running it fairly slowly, and OFS Tesseract is not incredibly fast. I've got a lot of other things running on the machine here, which doesn't help. But it started getting really, really exciting. And you can run this off a live camera input if you prefer. You can also just give it still images that you might be scraping from the web, or you can give it any other kind of video that you might shoot. So if I come to the code, we've seen in the header file we've included Tesseract. Here I load my video, I tell the video I just want it to loop, and I set the speed to be pretty slow, and then I tell it to start playing. And then I set up a timer to delay stuff, so I set a delay between how fast it's going to run the frames of the video, and I'm using this timer variable to say, get the system time. Has the system time increased above last time I timestamped it plus my gap, in which case fire a new frame. I set up my camera width and height if I was going to use a camera. And I'm loading in my typeface here that I want to use just so I can print out this stuff on the screen, make it look nice. And then there's a lot of different modes here that Tesseract can run. And I'm not going to go into them all because honestly I don't understand them. But you can see from their names the kind of things that Tesseract is optimized for depending upon what you think you're wanting to find. Blocks of text, single blocks, single words, characters, so on. And I've tried a bunch of them out, and some are faster and slower, some work more accurately and less accurately with the video, but all the documentation about Tesseract talks through what these defaults are better for. So this is running in block mode. And then in my update, so this is running every frame, I'm just going to update the video frame from the video grabber so we get the next frame from our video. And we say if our timer has passed our delay, in this case it was 300 milliseconds, get the pixels from my video frame and force us going to the next frame. So my image now is in the video frame. I set my color for drawing, and then I'm setting up some pieces on my image, width and height, and then I'm going to call Tesseract and pass it the pixel data from my image, tell it the width and the height of the thing I'm passing it, and also how many bits per pixel, what kind of color it is. And then I'm asking it to recognize whatever it can find in this image I've just given it when I've said set image. And it returns me an object, and then I'm going to iterate over this object, saying find me a block and find me the words inside that block. So I'm going to go through, and I've set up a bunch of integers, and this is going to return me the bounding box for any blocks that it finds. So I'm saying if we found a block, go through, and then draw a rectangle around the block if you found one, and then next to that block, wherever it is on the screen, which I've set here to be in red, draw a rectangle in red, and then set the drawing color to be white, and draw a bitmap screen of that word next to the block in white. And then I add the text that it found into my other string, so it's building up a string that I'm using down here, where my TrueType font that I loaded, I'm saying draw out the text, and I'm concatenating all these bits of text that I'm finding as I iterate through the objects that the Tesseract OCR software finds. And then I'm saying just print out that whole string of whatever you found in this frame across the bottom. And what I could do is say every 20 lines or 20 frames, I could add 20 lines of this text and print that out. Run a piece of video, grab 20 frames or 20 chunks of text, print that out as a 20-line machine poem. And then in my code, I'm just saying toggle full screen, and I can increase and decrease the frame delay with the key up and the key down to run it faster and slower. So when we run it, this is what we're getting. So run it up full screen. And if I press the up arrow, I can slow this down. If I press the down arrow, you'll see it's starting to speed up. So I've shortened the frame delay. So the video is actually a slow motion of a video, but now I'm increasing the rate that I'm scanning, and you can see it flying through. Where this OFX Tesseract, where the Tesseract system is finding a lot of objects, you can see it slowing down a little bit. There's ways that I can optimize this. But this is what I started making. And I was so excited, super excited about this, the beginning of exploring machine poetry out in the wild. I love to think, I keep saying this, machines are talking to us already, but we just don't understand what they're saying. And I think this is machines talking to us, or something. I don't know, Douglas Adams would probably know about this. So I was really excited about what was going on here. And I'm going to take this on. I'm not quite sure where. I don't know whether it becomes an installation or it becomes a mobile phone app for translating the language of machines. I'm not sure. Put some suggestions in the comments and let me know what you think. And if you do anything with this, let me know. The source code will be available online, and I'll see you on another video in the Art and Code series. Please hit the subscribe, hit the like, leave me some comments. It really helps keep me motivated to keep making videos. And good luck with coding. Let me know what you make, and I'll see you really soon. Thank you very much.